All right, so in our last video, we talked about identifying our line of symmetry, so our axis of symmetry, okay? So just as a quick recap, we did that by finding the opposite of B all over 2A, and then from there, we would find a vertex, right? We would plug in this value of our line of symmetry, and we'd plug it in to find our vertex, and then we were also able to find our y-intercept knowing, okay, come on. Sorry, it's a little touchy. We were able to find our y-intercept knowing that it was our c value. So one of the things we didn't talk about was, well, how do we know if we have a max or a min just by looking at the equation? How do I know that? And so we're going to talk about that right here. And so in this first example, you'll see I have 3x squared minus 2x minus 1. It is graphed right here, okay? I have that exact same equation, okay? And actually, I'm just going to erase this just so I have some room. But I have that exact same equation over here, except for there's a small difference. So see if you can notice that difference, and hopefully you're like, well, hey, oh, I just wrote over that. My a value, okay, one's positive and one's negative. So I can draw a conclusion from this, and that conclusion would be that when my a value is, I want to write this specifically, so let me just look at my notes really quick. So when my a value is specifically positive, so when a is positive, I have a minimum. And when my a value is negative, I'll have a maximum. And so what the a value does is it reflects it, or it flips it over. And so we can just real quick look at the following examples down here and determine whether or not I have a max or a min. And so here my a value is positive, so I'm going to have a minimum. Here my a value is negative, so I'll have a max. Now here, while I might have a fraction as my a value, which does have an effect on the graph, but we'll look at that later, the simple fact that it is positive tells me that I'll have a minimum. So we're going to take all this information, so the ability to find the axis of symmetry, find the vertex, y-intercept, and knowing that it is symmetrical so we can reflect in order to graph. So now like the first time we looked at graphing, we made an input-output table, that -2, -1, 0, 1, and 2. Now while that does work, it doesn't work every time because this parabola can move anywhere on the graph. So what I do know is that I can find my axis of symmetry first. So that opposite of B all over 2A. So that would be -4 all over 2 times 1. Or that's just -2. That's the line x equals -2. And it's an invisible line. And so when I go to -2, I like to usually just put like a dotted line because it's not really there, right? It's just we know that that's where the parabola is going to cut in half. So I know my parabola is going to be right around that dotted line. So in step 2, we'll find our vertex. We know we can find our vertex by plugging in our line of symmetry value of x, -2, into the equation. And so I'll do just that using parentheses. So that gives me 4 minus 8 plus 3. And that has a value of, let's see, this is -4 plus 3. Okay, so -1. And so I have a minimum. And now I know I have a minimum. Let's just talk about that really quick. I know it's a minimum because the a value is positive. So I have a minimum at -2, -1. So -2, -1. So I gotta do this strategically here, right here. So then step 3 is find my y-intercept. Well, my y-intercept is my c value. So I'll find my c value. There it is. And so now I can go ahead and I can actually reflect that. So if you look really closely at your graph, that point is 2 spaces away from my line of symmetry. So I'm going to go 2 spaces in the other direction, and that's going to be right here. And I have enough to go ahead and draw a line and make a curve, and there's my parabola. So that would be your step 4. So looking at our second example, So step 1, we're going to find our line of symmetry. So the opposite of B all over 2A, or negative 4 all over 2 times negative 2. Whoopsie. And so that's going to give me negative 4 over negative 4, or that's just going to be positive 1. So that's really convenient. And so from here, I'll go ahead and I'll sketch that graph. So that's going to be at 1, or I'm sorry, sketch the line of symmetry. So again, I like to make it dotted. And then from here, I can find my vertex. I will plug in 1, square it, plus 4 times 1 minus 1. Okay, so now I'm going to simplify it. So that's just going to be negative 2, right? So 1 squared is 1 times negative 2 is negative 2, plus 4 minus 1. And so when I add all that together, so let's see, negative 2 plus 4 is 2, minus 1 is 1. So I have a vertex at 1 and 1. And so what I like to do, I like to see if, am I going to have a max or am I going to have a min? So I can start to kind of picture what this graph is going to look like. And because I have a negative a value, I know I'm going to have a max. It flips the parabola upside down. So I know it's going to look like this. So then I'll go to the point 1 and 1. And I'll put a mark there. There's my vertex. Step 3 is the y-intercept. We know that's the c value, and that c value is negative 1. So that's the point 0, negative 1. And so I'll put my point right here. And remember, this is symmetrical, so I can go ahead and reflect that on the other side. And then I can kind of connect my points with the curve and kind of estimate what it's going to look like. And so for now number 3, same idea. So why don't you guys try this one on your own? So hopefully you started with the opposite of B all over 2A. So that converts to now positive 6 all over 2 times my A value. And that's super convenient. That's just 6 over 6, or that is just 1. And so again, I know I have a line of symmetry at x equals 1. So I put my dotted line there. Then step 2 is I'm going to find that vertex. So I'll put 3 and then insert 1, and I'll square it, minus 6 times 1 plus 2. So 1 squared is 1 times 3, 3. Negative 6 times 1 is negative 6, and I'll bring down the plus 2. So 3 minus 6 is negative 3, plus 2 is negative 1. So I have a vertex at the point 1, negative 1. Now, is this going to be a max or a min? Well, according to my a value being positive, I will have a min. And so I know my parabola is going to open upwards. So I can go ahead and go to the point 1, negative 1. There's my vertex. And then part 3 says to identify my y-intercept. Well, that's my c value, so that's my y-intercept is 2, or it's the point 0, 2. So I can go ahead and put a point there. So we go ahead and zoom up on the graph. So there's 0, 2. And again, I know that my parabola is symmetrical, so I'll go one more over in the opposite direction of that line of symmetry, and then go ahead and graph my curve. So then the last one, why don't you guys try, oh wait, I didn't even realize I had this slide. I'm sorry, let's go one more. So the last one is the application problem. So when are we ever going to look at parabolas? Like, how does that apply to real life? Anytime something is thrown up in the air, like you throw a ball or you kick a ball, or a rocket is launched in the air, that actually is creating a parabola. So in this instance, this example was pulled from a book. It says the cheerleaders at Lake High School launch a t-shirt into the crowd every time the Lakers score a touchdown. So the height of the t-shirt can be modeled by this function where h of x, so the outcome, represents the height, and x is the number of seconds it's been in the air. So now don't draw this, but if I'm launching it starting at a height of 6, it's going to go up, and then it's going to go down. So I know my parabola is going to look like that. So what I can go ahead and do is first I'm going to kind of find my notes here where I did this problem out. So here we go. So I can go ahead and I'm going to find my line of symmetry first. So I take the same first step. So the opposite of B all over 2A. And so that's going to be negative 48 all over 2 times negative 16. And that's going to reduce to negative 48 all over negative 32. And in this instance, we will use a decimal, which is positive 1.5. So I know there's my line of symmetry. And then I'm going to find my vertex. Not a whole lot of room here, but I'll plug this in. So I'll do negative 16 times 1.5 squared plus 48 times 1.5. And then, I could barely fit this in, but plus 6. So then I'll simplify this part, which is just 36, actually negative 36, plus, and then 48 times 1.5 is 72, plus 6. And then the whole thing comes out to be 42. Excuse me, I keep coughing, I apologize. And so I know my vertex is at the point 1.5 and 42. So what that means is, is that at 1.5 seconds, my the t-shirt is going to reach a maximum height of 42. But before I can graph this, I also know that my y-intercept is 6. So I have to make sure that this fits on the graph, right? So I want to make sure that when I'm labeling my graph, I go up by enough so that it can go all the way up to 42. So this is going to be time down here. And then my y is going to be the height. And so since it has to get up to a height of at least 42, I would make every single line, let's make it worth, I think 5 should work. So this would be 5, so then that makes this 10. And then I'll just kind of skip every other one. There's 20, there's 30. Maybe I should do this in a different color so you guys can see this better. So there's 30, there's 40. And then one more up here's 50. So I'm just barely fitting this in here. So it starts at approximately, it starts at 6 feet. So 6 feet is about right here. There's 6 feet. And then it says we reach a height at 1.5 seconds. And so now I almost forgot. I got to label my x-axis, right? And so we can actually space this out. So let's go up by 0.5. So this right here, let's make this 1, making this 2, 3, and then 4. I shouldn't need more than that. So at 1.5 seconds, I'm at about 42 feet. And so I'm going to approximate that to be about right here. Now, remember, this is symmetrical. So here's my line of symmetry. It should be an invisible line, right? So my t-shirt's going up. Now, I'm going to reflect my y-intercept of 6 on the other side. So I see it's 1, 2, 3 from that line of symmetry. So I'm going to go 1, 2, 3 in the opposite direction. And so that would be my reflected point. And then I'll kind of connect them and kind of approximate, where my t-shirt is landing. And so that allows me to answer part B and C. So what is the maximum height of the t-shirt? We just said is 42 feet. How long does it take the t-shirt? First of all, it took 1.5 seconds to reach its max height, but how long is it in the air for before it hits the ground? And I would say it's approximately 3.1 seconds. That's when the height is 0. And then that's it for this video.